Hi, I'm going to teach you the different voltages and power rails in a laptop motherboard. So let's get started. So let's begin here with the first controller. Here, as you can see, we have the CPU core. So we're gonna see all this circuit. As you can see here, if you understand basically this circuit over here or control IC, you can understand any motherboard. So those square here, as you can see, means circuit of the motherboard. So basically any motherboard contain many circuits. Is, for example, the CPU circuit, the 3-volt 5-volt circuit, the RAM circuit, the NOT bridge circuit, the charge IC circuit, etc. So I'm going to teach you the different voltages in every computer motherboard. If you follow me until the end of this video, I guarantee for you that you will understand any computer power rails. So let's get started. As you can see here, so let's begin, for example, with 5 volt, 3.3 volt. So this is two main voltages that you can find in every motherboard. So without these two voltages, the motherboard cannot be operated and working correctly, because all voltages in the motherboard are based on these two voltages: 5 volt, 3.3 volt, and the 19 volt, the main voltage. Okay, so here basically this is the 3 volt 5 volt controller or IC. Here in the left we have inputs, okay, and in the right over here we have outputs. So in order to generate, as you can see here, plus 5 volt always and plus 3 volt always, we call it always because these two voltages are always exist in the motherboard. Without pressing the power button, you should find these two motherboards. Once you connect the power adapter, these two voltages should be present without pressing the power button. Okay, that's why we called it always. Plus 5 volt always and plus 3 volt always. And sometimes we find in some computers or laptops plus 12 volt always. So here we have input and here we have the output. Okay, basically the part number for this IC, the control IC, is TPS 51125. Okay, so here we have the DC bat out. As you can see, this is the VIN, basically the voltage, the input voltage. And over here we have two enable signals. Okay, we have here an enable signal, as you can see here, power S5 enable. Do you see S5 stage? Here we have S5, means S5 means the laptop is the first stage of powering on the laptop. Okay, so here we have an enable signal that is generated in S5 state. Okay, so here these two are input signals. As you can see here, we have input signals. Okay, as you can see, this is the first input signal and this is the second input power. Here input signal because enable, and here input power, we have the input voltage. Then here we have output. As you can see, we have the first output signal. We will get, as you can see, the power good. Once this input are correct, so we have the power good. Okay, the power good means all powers are connected or all signals are present. And over here we have the output power. We will get then the V out 1 and V out 2, plus 5 volt always and plus 3 volt always. Okay, 6A means 6 amps. Okay, so that's it. Here we have inputs and over here we have outputs. Okay, I'm going to teach you or to explain to you in a schematic in detail. Okay, in the circuit diagram of 3 volt 5 volt circuit in detail. So let's now see the second circuit. Here we have, as you can see, the CPU core. Okay, the CPU core basically is for the processor. Its reference or part number is ISL6265. Okay, so if you want the details, for example, of this circuit, you can just go to Google and post and write ISL 6265, and you will find the circuit diagram in detail of this circuit. So I show you how. So let's go, for example, to Google. We have here ISL 6265. Okay, so let's type in here ISL 6265. Okay, datasheet, and press enter. So here let's pick, for example, the first result. We have here ISL datasheet download. Okay, this is the same circuit, so let's hit the first result. Here we go. So here basically this is a very important website that I use frequently, alldatasheet.com, because I find sometimes I want to study and to see the block diagram or the circuit diagram of a circuit, so I use frequently this website. This is a very interesting website. So here, as you can see, I have here ISL 6265. I have here a PDF file. Here we have 24p, means 24 page. Here, as you can see, we have multi-output controller with integrated MOSFET drivers for EMD SVI capable. So let's click in the PDF file in order to download it, and then here, as you can see, we have download. Let's click just over the part number ISL 6265 once again. So here we go. We have here ISL 6265 file is ready. As you can see here, we have 24 pages. Okay, one of 24 pages. So you can just simply click over here if you want to download it to your desktop. So let's download it, as you can see. So here we have a security code that we can enter. So let's enter the security code. So 51677, and just click download. So as you can see here, we download right now the PDF file. So the PDF file is downloaded, as you can see, done. So let's click over it. So you can do this for any integrated circuit or any components that you find in the motherboard. If you want to read about it and to know about it more, characteristics and its schematic, its block diagram, etc. So this is the first page. As you can see, you can read the features, etc. So let's move on, for example, to the second page. As you can see here, we have the pinout. Okay, the pinout over here. Okay, so let's see, we have the functional block diagram, as you can see, inside the IC. Basically, this block diagram or functional block diagram, you cannot find it in the schematic of the laptop. No, you cannot find it in the schematic, but in its datasheet, you will find this functional block diagram, as you can see. Okay, and of course we have electrical specifications, as you can see, including the enabled signals, how much, the temperature, the power, the maximum power. So all conditions, you will find the minimum and maximum values, as you can see. Let's go back to our schematic. So we have seen the datasheet of this IC. You can do the same thing for any IC here. You can just pick or take the part number of the IC and then go to Google, post it, and check for its datasheet. So here, using the same working principle, here, as you can see, we have input stage. Here we have input, and over here we have the output stage. Okay, so basically this IC is for what? Is for the CPU. Okay, so here we have the VID setting. The VID setting, we have the input signal. Basically here we have an enable signal. So guys, enable signal means, without it, means a control signal. It's like a key of the door. Without it, you cannot go in. Okay, so for the CPU, of course, it needs 19 volt power. As you can see here, we have 19 volt. As you can see over here, we have the input voltage 19 volt, and it needs also some identification IDs. Okay, so every processor or CPU has its own identification IDs. As you can see here, we have, as you can see, so this is identification IDs. So based on these IDs, the control IC can know the value of the power or of the vehicle that will generate, okay? Because there are some CPU that is powered with 1 volt, others, for example, with 1.2 volt, others 0.7 volt. But what is the thing that will determine or identify the right voltage? The IDs. The IDs of CPU. So this IDs is sent to this IC from the CPU. So from the CPU to the IC. Then this IC, after receiving these IDs and enable signals, it will then generate the plus VCC core. Here we have plus VCC core 0 and plus VCC core 1. So it means this IC has 2 channels, okay? 2 channels, because as you know, for the CPU circuit it has more than 1 channel. I will explain to you what does it mean channel, okay, in the next lecture. And also it will generate plus VDD NB, means for the NOT bridge, for the chipset near to the CPU, okay? So here we have inputs and here we have outputs. So let's move on to the next IC, as you can see here. So the next IC, as you can see here, we have the charge IC, or the control IC that will be charged to generate the voltage to charge the battery and to power the motherboard in the same time, okay? So here, of course, always we have inputs over here. As you can see here, we have input signal, okay? We have input signal here, okay? And we have input power. Of course, for any IC, it needs enables signals. Here we have enable signal, and here we have plus 3 volt, and the AD plus means what? Means adapter. We have DC in here. This IC should receive it the 19 volts. After receiving the 19 volt and this enable signal, it will then generate, as you can see, the V out, DC bat out, means the voltage to charge the battery. And over here we have the input or the adapter, okay, for the adapter, okay? So let's move on to the next IC. So here we have plus 1.1 volt for chip, means for chipset, including NOT bridge, including graphic card, including ICH or input output controller hub. So here, as you can see, we have also enable signal. Always we have here input signal and we have input power. So this IC take just plus 5 volt always. Okay, do you see 5 volt always? So that's why I told you that 5 volt always is a very important voltage. So this 5 volt always is the voltage generated by this IC. So this voltage goes directly here. Here this voltage is the output and here is the input. So this IC takes this voltage and then after receiving the enable signal, here we have S3. So this voltage is generated in the state 3. So guys, as I told you before, I put the link of the video where I explain the states in the description box. Please don't hesitate to watch that video. A very important video for every technician or engineer that want to go to become professional in hardware repair. So enable signal plus 5 volt. This IC will generate plus 1.1 volt for chips. Okay, so it goes until 9 amps, and of course it will generate also plus 3 volt always. Okay, so the next IC, as you can see over here, we have 1.8 volt and 0.9 volt. So this is basically for what? For RAM, random access memory. As I told you before, for random access memory, it has basically for any type of RAM 2 type of voltages, a main voltage and a voltage for terminals. So here it seems that the type of the RAM is DDR2. Here we have 1.8 volt and 0.9 volt. So this is DDR2. So for DDR1, the main voltage is 2.5 volt and the VTT voltage is 1.25 volt. For DDR2, we have 1.8 volt. The voltage for terminals or VTT 0.9 volt. For DDR3, 1.5 volt and 0.75 volt. DDR4 1.2 volt as a main voltage and for terminals 0.6 volt. For DDR5 1.1 volt for a main voltage and 0.55 volt for terminals. Okay, so this is the IC that will be generated 2 voltages for the RAM, as you can see. Here we have in the V out, as you can see, we have 1.8 volt and 0.9 volt for terminals. So here this is the input. Okay, and of course the power good. The power good means these voltages are generated correctly. Okay, just the power good, this IC inform the CPU, the big IC that is responsible for the whole power in the motherboard, that successfully generate my voltages. Okay, so it inform the SIO that these 2 voltages are generated correctly. Okay, so after receiving the enable signals, as you can see here in the S5 state, and receiving plus 5 volt always from this the first IC and 1.8 volt RAM, it will generate these 2 voltages. Then we have these 2 IC. Basically here the same working principle. This IC has a purpose to generate plus 1 volt also for chipsets, and this one plus 1.5 volt also for chipsets. So here always we have inputs and outputs. It will take the enable signal in state 3 and plus 5 volt from the first IC that we have seen before. As you can see here, this first IC we have plus 5 volt. Okay, then we have plus 5 volt plus enable signal. It will generate plus 1 volt, and the power good, it will inform the CPU that I'm successfully generate this voltage. The same for the last IC. We have here plus 1.8 volt and an enable signal. Okay, in the state 3, as you can see here, state 3 enable plus VCC. This is input signals. It will generate V out 1.5 volt and power okay or power good. So this is it, guys. This is the working principle how the voltages are working in the computer motherboard, the laptop power states. If you understand the working principle of these states, you can easily troubleshoot and repair any failed motherboard. So let's get started. So as you can see here, we have basically the states. Okay, we have S0 state, S1, S3, S5 and S4. Okay, so we have basically 6 states from S0 to S5. Okay, and over here we have the power plane, where we have the name of signals for the motherboard. We have the B+, basically B+ is the main power for any laptop, equal to 19 volt, usually 19 volt. We have the plus 3 VL, okay, we have the 5 volt and 3 volt always, and also we have 1.2 always, and we have 1.8 volt and 0.9 volt. This is basically the power for the RAM, random access memory. But for the RAM, as you know, there is many types of random access memory: DDR1, DDR2, DDR3, DDR4, DDR5, etc. So this power here, 1.8 volt and 0.9 volt, is for DDR2. Okay, so the RAM has basically 2 kinds of power: the main power and the power for VTT or for terminals. So for DDR1, the power is 2.5 volts and 1.25 volt for terminals. Okay, DDR2 we have 1.8 volt and 0.9 volt, always the half of the main power. For DDR3 1.5 volt and 0.75 volt. For DDR4 1.2 volt and 0.6 volt for VTT, and for DDR5 1.1 volt as a main power and 0.55 volt as a VTT. Okay, and over here we have other powers, as you can see, plus 5 volt, plus 3 volt, plus 2.5 volt, so plus 1.8 volt, 1.5 volt, 1.1 volt, and we have the VGA core. This is basically for the graphic cards. And over here, of course, we have other powers like CPU core. NB means North Bridge. Okay, the North Bridge. So this is basically the main power for the North Bridge or the chipset. Here we have the CPU core 0. Here basically we have 2 channels for CPU because the CPU or the processor has usually 2 channels or more. Okay, so let's begin with S5 state, as you can see. So basically S5 state means the sleep state, and S0 state means the whole working state. So if we go here, for example, here as you can see here we have the system working state, we have S0. Okay, so S0 means the system working state, and here if we go in this direction means S1, S3, S4 until S5 we have sleeping state. Okay, and of course from S5 to S0 we have the waking state. Okay, so here as you can see we have S5 and S4 with AC and battery don't exist, not connected, we don't have any voltage. This means nothing, we cannot get any voltage in the motherboard. So this mark means no voltage, this mark means the voltage exists. Okay, so here we have S5, S4 with battery only. When we have battery only, we can get just the plus B, the 19 volt with plus 3 VL. Okay, okay, but with the same state S5, S4. Here S5, S4 with the AC, we get another voltage. We get the plus 5 volt always, and 3 volt always, and 1.2 volt always. So if you connect just the battery, you cannot get these voltages, but with the AC you can get these voltages. But for this, the RAM and the CPU, etc., no voltages. Okay, okay. S3 we get the 3 kind of voltages with the battery or with the AC. Okay, we get the plus B voltage, the 19 volt, we get the always voltages like plus 5 volt and 3 volt, and also the RAM is powered. So the RAM is powered in S3 state. The CPU not yet. Here we have the CPU not yet. But in state where the CPU also is powered, we can get those voltages like the CPU core voltage and the CPU core for North Bridge and for the graphic card, etc. Okay, so the CPU voltage is usually about 0.8 volt and 1.2 volt. Okay, so for S0. So for the S0 also we get all voltages. Okay, so let's move on to the next slide. So now here I'm going to explain to you what is exactly the system power states in detail. So the system power states describe the power consumption of the system as a whole. The operating system supports 6 system power states, referred to as S0, fully on and operational, through S5, power off. So each state is characterized by the following: power consumption how much power does the computer use? Okay, because the power consumed by the laptop in S0, for example, is not like S5. S5 is the power off state, so no power is consumed. But S0, the laptop is in full operation. Okay, so it will consume more power. Okay, so the power consumption, how much power does the computer use? Then the software resumption. From what point does the operating system restart? And then the hardware latency. How long does it take to return the computer to the working state? Then we have here the system hardware context, such as the content of volatile processor registers, memory, caches, and RAM. How much system hardware context is retained? Must the operating system reboot to return to the working state? So, state S0 is the working state. States S1, S2, S3, and S4 are sleeping states, in which the computer appears off because of reduced power consumption, but retains enough context to return to working state without restarting the operating system. State S5 is the shutdown or off state. A system is waking when it is in transition from the shutdown state S5 or any sleeping state from S1 to S4 to the working state S0. And it is going to sleep when it is in transition from the working state to any sleep state or the shutdown state. The following figure shows the possible system power state transition. So as you can see here, we have this figure where we have the system working state S0 and any sleeping state from S1 to S5. So remember, these states S1, S3, S4 and S5 is different from each other in terms of power consumption and the amount of sleeping state. So when we go from here, from S0 to S5, we are in sleeping direction, and vice versa. From S5 to S0, we are in waking direction. So as the figure shows, the system cannot enter one sleep state directly from another. No, it must always enter the working state before entering any sleep state. For example, a system cannot transition from state S2 to S4, nor from state S4 to S2. It must first return to S0, where we have the whole or the full working, from which it can enter the next sleep state, because a system in an intermediate sleep state has already lost some operating context. It must return to the working state to restore the context before it can make an additional state transition. So this is all about the laptop or motherboard states S0, S1, S3, S4 and S5. So I hope you understand the video, because this context or this states is not easy to understand, but please just repeat the video 2 or 3 times and you will understand what I'm saying. And please don't forget to like the video, subscribe and share the video if you like it. And for anyone who wants to improve its skills and information, you can join me in the Patreon page, where I share more and more exclusive content. Thank you very much.